Welcome back everyone. In this video, we'll discuss the solutions for the exercises that we have posted at the last part of the strings video. So if you haven't watched that video yet, I highly encourage you to watch it because some of the methods that we will be using is directly lifted from that video. So without further ado, let's start coding. For first exercise, we're going to count the vowels in a string. Vowels are the letters A, E, I, O, and U. So let's write a function that will loop through each of the character and check if it's a vowel. So press A here to add another cell. Okay, so we'll call the function count vowels. Okay, and we have here the text. So we want to first define what the vowels are. And it's A, E, I, O, U, and the capital A. And of course, we want to initialize a count variable. For most of our exercises, we initialize an empty variable which we will then return by the end of the function. So the count will be 0, meaning at the beginning of the function, this is 0. Now, we loop for each character. In the text, or whatever we supply here, whatever string we supply here, and check if the element or character is in the vowels. Okay, so here's how it goes. For char or character in text, if char is in, so basically in the video for strings, we've taught you string comparison and of course the use of in. If that letter is in vowels, then we will proceed to add 1 to the vowel count. And of course, if none, we just continue with the loop. And at the end of it, we want to return the count. So we want to test the function now. Let's say count the vowels for Berlin. So there's 2, E and I. For exercise number 2, we are to create a function that checks if a string is a palindrome. Now, a palindrome is a word, phrase, number, or any other sequence that reads the same forward and backward, of course ignoring the spaces, capitalization, and punctuation. Given that characteristics, we will now write a function based on what we learned as well, and also we'll be teaching you one technique that I haven't shown in the past video, but that technique can be applied to this as well. So let's say here we want to call this the palindrome checker, or maybe just is palindrome, which should give you just a boolean for true and false, and you have here the text. Okay, so the first thing we need to do is, as we've defined the palindrome, it ignores spaces, capitalization, and punctuation. We need to lower first lower the text, as palindrome ignores capitalization. So the text will be text.lower. Recall, you need to actually assign it for the method's effect to be permanent. Now, we will now declare here a variable. So here's the remove the spaces and punctuations using a loop. So actually, you can get the cleaned text here. It's an empty string first. Okay. And so we now loop through each of the letters. So for character in text, okay, for the character in text. So, if the character dot is alnum, okay, clean text equals the current clean text plus the character, or one simple way to do this, okay, would just be to write cleaned text plus equal char. Okay, take a moment to understand this. This is essentially read similarly to this. Okay, it's a plus equal means that you are adding the current element to the variable and simultaneously reassigning it to that variable. Okay, so okay, remove this. Okay, and we want to return and check if the clean text is equal to the inverse of that. So let me explain to you what's happening here. Okay, first, I think this might be a little bit new. If you've watched the string video, this is new. Basically, that is alnum, sorry, this alnum is checking if the character is alphanumeric. So it will return true if it's just an alphabet or a number. So let's say, for example, A that is alnum, alphanumeric. It will say true. If it's a number, it will say true as well. But if it's a punctuation mark, it will say false. So if it's an alphanumeric, if you loop through the text and it's an alphanumeric character, then we execute this. We add that clean text to this empty variable. Now this one here, supposed to be equals equals, is reversing that particular text. So for example, if you have here Python and then say here, let's say test variable is Python, and you wanna reverse it. If you wanna reverse it, this is one simple way. It's like the index method, and you put in two colon and put in -1. It's like saying inverse whatever or reverse whatever is test variable. So you'll see here it's Python reversed. It only doesn't just work with strings, it also works with lists. So let's say, for example, for Python, to make that as a list, okay, we could do this, okay, and maybe you can just call this test list. So note that if you call on the test list, you have the letters of Python spelled or in the position as how you would spell them if they are words. But if you apply the same method, the square bracket, colon, colon, -1, it also reverses that particular list. So basically, what we're saying here, when you've cleaned the text of its punctuation and of course its capitalization and spaces, then is it the same as its reverse version? If it's the same as its reverse version, this function will return true. So let's test that for now. So in this particular case is Palindrom. We want to check if, let's say, it's no lemon, no melon. Okay. Okay, clean text is that, sorry, it's supposed to be cleaned text. Okay, and there you find out that this is a palindrome. So let's say, for example, the word madam. The word madam is a palindrome. Or if you want to try as well, was it a car or a cat I saw? If you want to check if the function likewise returns false for sentences or phrases or sequences that are not a palindrome, then let's try this one, and you can see that it's a false. For the last exercise, we are to create a function that rotates each letter in a string by 13 positions in the alphabet, or what is known as the ROT13 encryption. So you may be familiar with what encryption does, and encryption is the process of transforming information into a coded format so that not everyone can understand what that message or what that the information is. So of course you want to apply that if you're trying to protect some confidential information. And while there are different levels and types of encryption, ROT13 is a very basic one, which is sometimes used for puzzles, coding basic messages, and it's short for rotate by 13 places. ROT13 is rotate by 13 places. It's a simple substitution cipher that is used to obscure the text. It works by replacing each letter with the one that is 13 positions after it. So for example, if you get the letter A, that all the letter A in that message will become letter N. And if you have the letter B, then what's 13 places after B, that's O. So all the letter B's in your messages or message becomes the letter O. So let's begin. So for this function, we will be needing the built-in functions of ORD. Here's the ORD and CHR. Okay. So what does ORD does? Well, ORD takes a single character, usually an alphanumeric character, and turns it into its corresponding Unicode or ASCII code. So let's put that here. ORD takes a character, and it's required that the parameter here, or that it only takes one character, one string, and returns its Unicode or ASCII. Okay, so for A, you know that it's 97. The capitalized A is 65. And CHR likewise does the reverse of what OR does. It takes an integer and returns the alphanumeric equivalent of that integer, or it assumes that that integer is the Unicode and returns to you the alphanumeric equivalent of that. So let's try that. To reverse that, you want the CHR of 65 and it will give you A. So now that we have that, we can technically use those two functions to write our ROT13 function. So to start, let's maybe call our function rotate word. Okay, and maybe here we have the text. In this particular function, I'd like to introduce another parameter, which is shift, which of course we will be setting to 13 because it's rotate 13. But of course, for those of you who want to try the variation that is not just 13, so ROT13 is rotate by 13. So maybe you'd like to try other integers other than 13, you're free to do so. So, and as we have done earlier, we will create empty list to store our text. Actually, it can also be an empty string, but for now, let's use this and loop through. Now, for char in text, we want to test if the character is an alphanumeric character. because if it's a punctuation, or let's say, or a space, we keep it as is. Okay, we keep it as is. So we've seen that in the last exercise. If the character is alphanumeric, then we will shift that letter. To shift that, we first need to change the character into an integer, and you've seen that. How do we do that? By using the OR function. It's the char, and you will add in here the shift, which we defined or made as 13 as a default number. So this will be plus 13. Now, of course, if it's lowercase, handle the wraparound. So if character that is lower, because you know that the capital A and the small a has a different Unicode, then right, we'll explain that in a while. Okay. So basically, if the character is lower, this will return true. We want to test if the shifted is greater than the order of z, meaning it actually went over the value for the order of z. So let's test that here. So for example, the order of a is 97. So you know already that if you would look at z, it will be 122 because it will just add 26, right? So same with a, it's 65, and of course, in order for you to know what value is associated with z, you will just add 26. So it means that if those numbers, what the resulting number here is greater than that of z, then what would happen is that it would provide you a different character, so no longer alphanumeric. So for example, CHR of 91, we'll check that it's no longer alphanumeric, and it won't be easy for you to interpret that. So you want to ensure that, for example, the shifted value would be 91. You want to subtract 26 so that it will go back, it will wrap around. So after z, it now be a, b, c, d. Same with the smaller z, for example, 122. If the value that has been produced by this operation, the shifted old char, where we're turning it, so maybe put here, turn into Unicode, exceed that of the letter z, for example, that's 122. So let's say, for example, the new value is 135, right? Because you added 13, and it's very possible that it exceeds that. So now it will give you something that is not alphanumeric and very difficult to make sense. So what you do is that you subtract 26 so that it goes around that value and starts again from A, B, C, D. That's the wraparound. Okay? And per character, after doing this, so this is handling the wraparound, which is inside this for loop. So we have a it's a condition to handle that. Then after going through all of that, we now append but what we will append is not the integer, but rather the character already. Okay. All right, so it's supposed to be here, right? Because you want to append here the alphanumeric one. But if it's not, so if it's not an alphanumeric variable or character, meaning it's a space or a dot or a question mark, then you just want to go ahead and append that one. But of course, you're not going to change it, so it's really just append the character. Right? So now here we'll use the return function, and what we're going to return will just be to join whatever is found in the result. Okay, so we can try that. So for example, we want to try for our professor, right? Rotate word, and we want the professor, and we want to we'll give the 13, rotate it by 13 places. You have this. Now you see why sometimes you want to encrypt the message, because sometimes it's very sensitive. So let's say for example, let us attack by midnight. So encryption would somehow garble or scramble the message so that it's not easily understandable by the casual reader. So there. And that's it for today's video. We've actually covered a lot, even started with the basics of encryption. And hopefully the discussion or you applying what you've learned both from the past video and in this one actually further solidified your understanding of the string and makes you a little bit more confident with dealing or manipulating strings and incorporating them into your code. So until the next video, bye now.